Welcome to Global Tutors YouTube channel. I am the Angel of Maths. Now, in today's class, we'll be looking at the part 2 of the previous class we did, that is partial differentiation. Now, today we'll be looking at how to carry out partial differentiation using first principle, okay? Because sometimes they will give you this type of question. They know that it is very easy to solve, that every common man can do it. You understand, like the one we did in our previous class. So they will be like, simplify this or get this using first principle. So the purpose of this class is for me to make this to be very easy, okay? To make it to be very easy and simple. So let's get to the deal. Now, question number 1 we have says f of x comma y is equal to 3x squared over y. So we're asked to find f of x, then f of y. Now, in our previous class, I explained what f sub x means and what f sub y means. I said that when you have f sub x, which they can still give in this form, f sub x of x comma y, it can, if you have f of y, it can still be represented as f sub y bracket x comma y. That this means the first derivative of the function with respect to x. Remember that this is partial differentiation. So this is a first derivative of the function with respect to x. This means first derivative of the function with respect to y. So now we want to solve this using first principle, because using the trivial method is very easy, okay? It is very easy. The general rule is very easy. Okay, before we go or before we solve, we are going to solve this using the trivial method, okay, or the easiest method that everybody knows. Then we will now apply first principle, okay? So now, if we are to solve this, we have that f of x comma y is equal to 3x squared over y. Now, from my explanation in our previous class, I said that when you're working on this, if you're differentiating with respect to x, it means that everything about y is a constant. And if you're differentiating with respect to y, it means that everything about x is a what? A constant. So here, if we're looking for f of x, it means that y is a constant. And if we're looking for f of y, it means that x is a constant. So let us do it using that method, then we'll go to what we have today. So getting f of x here, before we solve this, let us make it in such a way that it will be very easy for us. So let us separate the constant from what we are working on. So our constant here, if we're looking for f of x, so our constant here will be 3 over y, then x squared, because 3 over y times x squared will give you 3x squared over y. So this will be our constant if we're working with respect to x. Now, if we're working with respect to y, we can still do this in this way. Then we have 3x squared dot 1 over y. You know, this and this is the same thing. When you multiply them, you still get to this, okay? So here, if I will need f of x, put something as the f over the x, partial differentiation. So my constant here is 3 over y. 3 over y. So when I work on this, if I differentiate x squared with respect to x, I will get 2x. So when I multiply everything, I will have 2 times 3, that is 6x over y, as easy as ABCD. So what you need to be doing is to understand the principle, okay? To understand the principle. Partial differentiation is very easy. It is very, very easy compared to ordinary differentiation. Because in this one, if you're working with respect to a variable, every other variable comes to a constant. So it makes our life beautiful. So in this one now, if we're looking for f of y, the same thing. Since I'm working with respect to y, everything about x becomes a constant. So this makes your life easy, okay? It is stress-free. It is stress-free. You don't bother about anything. Just remove what you need to remove, then take what you need to take. So from this now, what will be our constant? I'm working with respect to y. So what will be my constant now with the 3s to the second power? Because this is 3s squared y, 3s squared over y. So this is something else. I can still write this as a 3s squared y to negative 1. The laws of indices, don't forget. y to negative 1 means 1 over y. So if I multiply with this, I'll still get back to this. So I'm working with respect to y, not with respect to x. So this is 3x squared, which is my constant because I'm working with respect to y. So I'll have 3x squared times, when I differentiate y to negative 1, minus 1 will come down. Then I will have y to minus 1 will give me minus 2. So if I multiply everything I have, I'm going to have minus 3x squared y to negative 2, which is something as minus 3x squared over y squared. So for our f of x, we obtained 6x over y. Then for our f of y, we obtained minus 3x squared over y squared. So now let us use the principle. That's the first principle. Let us use this method and see if we are going to arrive at these answers. So the video will be a bit long, okay? It will be a bit long, but I believe it will be interesting. So make sure you have something with you, okay? Even if it is ice cream or anything, just keep yourself busy. Okay, let me make a space. Now, how do we carry out first principle? First principle is like make use of Cartesian plane. You are using a graph to solve, whereby there is an increment in arguments. Okay, when I say argument, I'm talking about the variables we have, either x or y. So look at what I mean. Like here, they said f of x comma y is equal to this. So I'm going to give us general rule. Okay, I'm going to give us a general rule. But before we start using general rule, let me make 1 or 2 explanations before we proceed. So if we have that f of x comma y is equal to, let's say that u is equal to this. Let's assume that u is equal to f of x comma y. Let's say this is this function. Now, if this is this, for me to have an increment in this function, it means that there must be an increment in one of the variables or two of them at the same time. So look at what I mean. So if I have u plus change in u, now this implies that there is a change in x or there is a change in y. So I can have f bracket x plus change in x comma y. So in such a way that if I make change in u the subject formula, I'm going to have f of x plus change in x comma y minus u. Now remember that u is equal to this, such that my change in u will be equal to f of x plus change in x comma y minus my u is f of x comma y. Now, if I want to differentiate this function, because here I can differentiate this function with respect to x or with respect to what? Y. So since there is change in x, let me divide both sides by changing x. So divide both sides by changing x. Divide both sides by changing x. So if I should do that, I'll have change in u over change in x. This will be equal to f into x plus change in x comma y minus f bracket x comma y over change in x. Now, taking the limit as change in x approaches 0 is what we call differentiation. Okay, so du dx, the partial differentiation of this function, is the same thing as the limit as change in x approaches 0 of this, which is the same thing as limit as change in x approaches 0 of this, f of x plus change in x comma y minus f of x comma y over change in x. So you can be like, let this change in x be h, or let the change in x be what? K. So this we did for x is applicable to y. So I can come to a conclusion that whenever I want to carry out first principle, I will apply this principle, I will apply this method than proving it all over again. So what I have to be doing is that once I am solving anything using first principle, I will just come to this. I will use this limit as change in x goes to 0, I will solve. So for instance, now if I'm looking for f of x, which is something as change in f over change in x, so I will take that this is the same thing as f of x plus change in x. So you can use change in x or you can use a letter. Let's say h. I can use change in x or I can use h. H, comma y minus f of x, comma y over h. Remember that you take your limits as h approaches 0. So I'm using h here because I'm using this h to represent change in x. You can still use change in x here. Okay, this is s plus change in s comma y, s plus h comma y minus f of s comma y, which is this over h. So here I'm using change in x. So they are still the same thing. Okay, they are still the same thing. So now let's get to the question we have. Let's get to the question we have. So from question number 1, so let me get rid of this. So question number 1, we are asked to solve this. F of x comma y equal to 3x squared over y. So I want to solve this using first principle. So this is the formula I am going to use. I have proved it. So there's no need proving it. What you have to do is that once you see first principle, just note that what you are required of is nothing but this. Okay, just bring down this, then with this you can solve. Okay, with this you can solve. So from the question now, our f of s is already given, f of s comma y. So from this question, f of s comma y is given as 3x squared over y. Now I have gotten this. Next I need this one, f of s plus h, f of s plus h comma y. So how do I get this? So since f of s comma y is this, then f of x plus h comma y will now be, it means that there is an increment in x. So the increment in x is what? H. So I will make that increment here. So this will be equal to 3. This is x. Anywhere I see x now, because this is margin to this. Anywhere I see x, I will replace it by x plus h. So this is x. I will now change it to x plus h. Now this has a power of 2, so I'll put power of 2 over what? Y. So this is my x, f of x plus h comma y. So I will go to this and substitute everything. Life is simple, life is beautiful. Okay, mathematics is easy. The only thing there is, are you ready to obey? Can you follow the principle? That's all. If you can follow the principles, you will never have any problems. So now let's substitute in what we have. Our f of x, put something as the f dx, will be equal to limits as h approaches 0. This h means change in x, don't forget. So f of x plus h comma y. So this is the same thing as this 3 bracket x plus h all squared over y minus f of x comma y, which is this 3x squared over y, then everything over h. Everything over h. So let's simplify this. Let us simplify this. Remember that after solving this now, the answer we are expecting is that our f of x will be equal to 6x over what? Y. So let us see whether it will work. But I know that you are following the right principle. When you are doing the right thing, you obtain the right thing at the end. Okay? Mathematics, magicians don't solve mathematics. Okay? If you don't know the rule or the principle, you don't know it and you will never get it. Okay? So now let's get to the deal. So here this will be equal to limit as h goes to 0. So let us expand this. This is 3 into, this is x plus h to the second power. It means x plus h, s plus h. If you expand this, x squared plus this times this, sh, that is 2sh plus h squared. So this is what I have, s squared plus 2xh plus h squared minus 3x squared over y. This is still over y. Everything over h. So we are still solving. We are still solving. This will be equal to the f dx, that is our f of x, f sub x, will be equal to limit as h goes to 0. Expanding this, I will have 3x squared plus 6sh plus 3h squared over y minus 3x squared over y. Everything all over h. So let me make some space here. So At this point now, we can find LCM. LCM of y and y is y. So we can find LCM here. Our f of x will be equal to limit as h goes to 0. Then our LCM here is y. So y in y is 1. 1 times everything will give us the whole of the numerator. 3x squared plus 6sh plus 3h squared minus y and y will give us 1. 1 times 3x squared will give us 3x squared. Everything over h. So what next? We collect like terms. Okay, we collect like terms. For those of you in photo, remember Maths 101. We did all these things. Okay, we did all these things. So collecting like terms, this and this can what? Go. Because this is 3x squared minus 3x squared. Both of them can eliminate themselves. So this goes with this. What are we left out with? We have that f of x will be equal to limit as h goes to 0, 6sh plus 3h squared over h. So as you can see, we have h here and we have h here. We have here, so we can factor out one of the h to go with this. Then we take our limit as h approaches 0. Okay, that is the next thing we are going to do. Okay, this is over y. Sorry, this is over y, then over h. Don't forget, over y and over h. So this is what we have. So I can invert this fraction. I can invert this fraction. So inverting this fraction, I can do this over 1. I can do this over 1. That is what I mean by fraction inversion. So my f of x will be equal to limit as h goes to 0 of 6sh plus 3h squared over y times 1 over h. Times 1 over h. So let me make some space here. Let me make some space here. So our f of x will be equal to, I can factor out one of the h here. I can factor out one of the h here. So I will have limit as h goes to 0. I factor out one of the h. So I'll have h into, I will be left out with 6x here plus 3h here over y times 1 over h. So this h will take care of this h. So I'm left out with f of x is equal to limit as h approaches 0. So I'll have 6x plus 3h over y. Now remember that our limit is such that h is approaching 0. Okay? Remember Maths 102. So this is now limit. H is approaching 0. It implies that any place I see h, I should replace it with 0. So my h will now turn to 0. So this is to tell me that my f of x will be equal to 6x plus 3 bracket 0 over y, which is the same thing as 6x plus 0 over y, which is equal to 6x plus 0 will give me 6x over y. So this tells us that our f of x is equal to 6x over y. So this is what we have. So if you compare with what we have initially, you find out that they are the same thing. Give to Caesar what belongs to Caesar. Give to God what belongs to God. So let's solve question number 2. That is II. We are asked to find f of y. That is the f dy. It is still the same principle. Okay? But in this one now, the change now will be for y. When you're solving for f of x, we are using f bracket x plus h comma y minus this. So if you are solving for y now, f of y, it means that the change occurred in y, not in x. Okay, so let us formulate this. Let us formulate this. So let me make a space here. Let me make a space here. Make a space here. So now we are looking for f of y. So which formula are we going to use? It is still the same formula. So our f of y, our f sub y will be equal to the f dy will still be equal to limit as, you can use h or you can use any letter. So let me use k. Limit as k approaches 0. So you can use anything. If you want to use k here, there is no problem. Just note that it means what? An increment. Okay? Just note that it means an increment. So I have f bracket x. Since the increment is for y, so it will now be bracket, okay, comma, y plus, what is the increment? Let my increment be k minus f of x comma y over k. So this is what I have. This is what I have. So now, what I'm going to do now is this. I am going to obtain my f of s comma y plus k, and I'm going to obtain my f of s comma y from this. Okay, once I obtain it from the function, I will substitute it here. Okay, once I obtain it from the function, I will substitute it here. So from all indication, what I have is that f of s comma y is equal to this. So this is telling us that there is an increment in y. What is the increment in y? K. So we are going to go to this. So our f of s comma y is equal to 3s squared over y. So now we are going to look for f of s comma y plus k. F of s comma y plus k. It means that there is an increment in y. The increment in y is what? K. So any place you see y, you replace it with y plus k. So what I'm going to have now, look at y here. So this will be 3s squared over, so my y will now change to y plus k. This is very simple and very easy. Just do what you are asked to do. That's all. I know what I'm saying. Oh yeah. And start doing another thing. I'm telling you, in fact, the Reverend Father will leave the church for you and start going. Just do what you're asked to do. And don't forget to practice. Are you getting me now? Practice it to the core. You that is looking at me, practice it. Okay? This is not a joke. In Futo, if you're not your own boss, in fact, you will keep failing until your village people will decide to run. So, you need to be your own boss. That's what I mean. Okay? Angel of Mass is not a guy name. I know the reason why I'm saying this. Okay? So let us continue with what we are doing. So now, this is what we have. Okay? This is freakingly what we have. What are we going to do with it? You go to this. Any place you see this, you put this one. Any place you see this, you put this one. You know how I got it? We got it together. I didn't get it alone. Okay? So let us go and substitute. So now, f of y will be equal to the f dy, which is something as limit as k goes to 0. So k is the change in y. So this is f of s comma y plus k. F of s comma y plus k is something as 3s squared. So we have 3x squared over y plus k minus, what is f of s comma y? F of s comma y is equal to 3s squared over y. So this one will give us 3s squared over y. So everything will now be over k. So everything will now be over what? K. So what next? Here we are going to find LCM. Here. So what is our LCM? Our LCM is the product of this and this. Okay. So our f of y will now be equal to limits as k goes to 0. So our LCM here will be y bracket y plus k. So y plus k goes here will give us y. So here we are going to be left out with y plus k. Here will give us y. So y times this will give us 3x squared y minus, when y goes here, it will give us y plus k. So we're going to have 3x squared bracket y plus k. So everything will now be over what? K. We simplify. This is what you already know. Okay, this is what you already know. So now, our f of y will be equal to limits as k goes to 0 of 3x squared y minus, so this times this will now give us minus 3x squared y minus this times this will still give us minus 3x squared what? K. Minus this times this will give us minus 3x squared y minus this times this will give us minus 3x squared k. Everything over y bracket y plus k over k. So we're going to expand this one. So, but before then, look at this and this. Okay, if we should collect like terms now, you find out that this animal will take care of this animal. Both of them will go. So what are we left out with now? So let me make some space here. So we have that f of y will be equal to limit as k goes to 0. So we are left out with minus 3x squared k over, so let us expand this. We are going to have y squared, y times y is y squared, y times k will give us plus yk over k. So we can invert this fraction, we can invert it, fraction inversion. So our f of y will be equal to limit as k goes to 0, limit as k goes to 0. So this will give us minus 3x squared k over y squared plus yk times 1 over k. So as you can see, there is k below and there is k above. So let us do justice, okay? This k can take care of this k. So what are we left out with? Our f of y will be equal to limit as y goes to 0. So we are left out with minus 3x squared over y squared plus yk. So it is now time to take our limit as y as k, our limit as k approaches 0. So what does that imply? Anywhere you see k, put it here 0. Okay, just do justice. Okay, so let me make some space here. Let me make some space here. So our f of y will be equal to limit as k goes to 0. So any place we see k, we put it 0. So this will be minus 3x squared over y squared plus yk. So this will be y bracket. Our k is now 0. So this will be equal to minus 3x squared over y squared plus 0, which is something as minus 3x squared over y squared. So this is what we obtained. So let us check if it is exactly what we got before. So as you can see, our f of y is equal to minus 3x squared over y squared. So anyhow you take it, you will get it. Okay, first principle is just that it is long, but if you use it, you still get the same thing you obtain using the general method, which is this. Remember, when we solved it using the general method, we separated the constant from what we're working on. This is what we got for f of y, minus 3x squared over this. If you use first principle, you will still arrive at it. Okay, if you use first principle, you will still arrive at that. Okay, so now the next thing we're going to do now is this. Before we go to question number 2, I would like you to take your time and do it. Okay, just pause the video, do it. Okay, just pause the video and do it before we continue. Okay, I repeat, just pause the video. I say pause the video and continue. Pause the video. Okay, then you carry it up. So we continue. Okay, we continue. I hope you have done it. Okay, I hope you have done it. So now let's go to question number 2. We are given f of x comma y equal to x squared y plus xy squared. Then we're asked to find f of x and f of y using first principle. You can do this on your own. Okay, there is no need of me doing it, but let's do it in collaboration. Okay, now before we use first principle, let us use general method and solve it and see what we're going to obtain. So here, our f of x comma y is equal to x squared y plus x y squared. So let us get our f of x. Let us get our f of x and also our f of y. So our f of x means differentiate the function partially with respect to x. So everything about y will be what? Constant. So here is y and here is x. So our constant here is y times, when we differentiate x here we have 2x plus our constant here is y squared. When we differentiate x we have 1. So this implies that f of s is 2xy plus y squared. So after solving anything we are going to do now using first principle, our f of x should give us 2xy plus y squared. So now let us solve for f of y. Let us solve for f of y. So f of y will be equal to, it means that everything about x now is a constant. So s squared here is our constant, dot, when we differentiate y we get 1 plus, getting to here, s is our constant, When we differentiate y squared, we get 2y. So our fy is equal to x squared plus 2xy. So our fy will be equal to x squared plus 2xy. So this is to tell us that if we should use first principle to solve this, we should obtain our f of x, fs to be this, then we should obtain our fy to be this. So now let's get to the deal. Let us use the principle, or let us use first principle to do this. So we start. So now remember our formula, okay? Remember our formula. If you are looking for f of x, it means that there will be a change or an increment in x. If you are looking for f of y, it means that there will be a change or an increment in y. So don't forget. So for f of x, so let my increment be h. So I will be taking limit as h approaches 0. Then f of x plus h comma y, there is an increment in h, minus f of x comma y over h. Now from my function, I am given f of x comma y already, which is this. So from this now, I will get f of x plus h comma y. So we know that our f of x comma y is equal to x squared y plus x y squared. So this is telling us that f of x plus h comma y will be equal to, it means x is being incremented by h. So any place we see s, we now change it to s plus h. Y remains the same, okay? Y remains the same. So this is x. So this s will now change to x plus h all squared. Then there is y here plus, this is x, then x plus h, then we have y squared. So this is what we have. So we are going to substitute these things here, because once you have obtained the formula, get the things that are needed, substitute it there, then evaluate and get your answer. Make your life beautiful. So now our f of x will be equal to limit as h goes to 0. What is f of x plus h comma y? It is this. So what we have here is x plus h all squared y plus x plus hy squared minus, what is f of x comma y? Our f of x comma y is the same thing as x squared y plus xy squared, okay? Everything over h. So let us simplify what we have. Let's simplify what we have. So our f of x here will be equal to limit as h goes to 0. Then expanding this, we're going to have s times x is x squared plus 2xh plus h squared bracket y plus, then this one will give us xy squared, s times this xy squared plus hy squared. So let the minus enter. Let me make some space here. Minus x squared y minus xy squared over h. So let me bring it up here. So let us expand this. Our f of x will be equal to, limit as h goes to 0. So expanding this, x squared times this will give us x squared y. This times this will give us plus 2xyh plus h squared y plus, so what we have here is xy squared. So as you can see, this is sy squared, this is also xy squared. So this one can eliminate this one. So let us eliminate from here. This is positive xy squared, this is negative sy squared. So let both of them go. So the next thing I'm going to write now would be, I have written this. So this one is already gone. Okay, so I should have plus hy squared plus hy squared. Okay, so let's check what we did. S squared times this will give us x squared y plus 2sh plus h squared y plus, this one is gone. Okay, this is gone with this. So we are now left out with hy squared. Okay, we are now left out with hy squared minus x squared y. So minus x squared y, everything will be over h. Okay, this is what we have. Everything will be over h. So if we proceed this further, we're going to have that our f of x will be equal to, limit as h goes to 0. Now look at this. This is x squared y minus x squared y. So both of them can go, okay? They both can go. So this can go with this. This can go with this. So we are left out with 2xyh plus, look at this and this. Look at this and this. This is 2xyh plus this will give us what? This one now will give us plus h squared y plus hy squared, everything over h. So this is what we have. Now at this point, looking at it with our church mind, what do we think? Remember that whenever you are doing this, try to factor at h. Okay? Try to factor at h. Very, very important. If you're working with respect to k, at the end, try to factor at k. Eliminate the k that is under or the h at the under before you take your limit. Please don't make this mistake. Always eliminate that increment or that argument before you take your limit. So now we can factor at h. Our f of s will be equal to limit as h goes to 0. We factor at h here. We are going to left out with 2xy plus h squared. Okay, hy, because I have removed one of the h, plus y squared over h. H cancels h. So our f of x will be equal to limit as h goes to 0 of 2xy plus hy plus y squared. Now, limit as h approaches 0. So any place you see h, replace it with 0. So our f of x will be equal to 2xy plus, this is h, 0 bracket y plus y squared. So this tells us that our f of x will be equal to 2xy plus 0 times this is 0, so gone. We have plus y squared. So is it the same thing with what we obtained initially? Let's check. F of s is equals to 2xy plus y squared. F of s is equals to 2xy plus y squared. So they are the same thing. Okay? If you do it rightly, you will get it. So just try and practice this. Practice, practice, practice. Now, before we go to question number II, try and solve it. Okay? Pause the video and solve it. So now we continue. Now we're going to get our f of y. Okay? We're going to get our f of y. Although I know that you have solved it and you have gotten the answer. But now let us solve it together. Now for f of y, we know that whenever we're looking for f of y, it means that there is an increment in y. Okay? There is an increment in y. So let us formulate our formula. So let the increment be k. So we're taking limits as k goes to 0. F of x, comma, y plus k, because the increment is now in k, because we're looking for f of y, because change in y. So minus f of x, comma, y over k. So now what we're going to do now is this. We'll go to what we have, the function we have. Now at this time, there is an increment in y. There is an increment in y. So our f of s, comma, y, f of s, comma, y is equal to x squared y plus xy squared. So we are now looking for f of x, comma, y plus k. So at this time, there is an increment in k, there is an increment in y, which is k. So any place you see y, you change it with y plus k. So this will give us x squared bracket y plus k plus x bracket y plus k all squared. So time to substitute, direct substitution. So we go to this and substitute what we have. So we are going to have that limit as k goes to 0. Then f of s, comma, y plus k is this. So I will copy and paste. So okay, let me write my f of y. Okay, f sub y will be equal to limit as k goes to 0. So this is something as x squared bracket y plus k plus x bracket y plus k all squared minus f of s, comma, y is something as x squared y plus xy squared. So this is what we have. So everything over k. So now let us simplify what we have. So if we should expand this, our f of y, if we should expand that, our f of y will be equal to x squared times this will give us x squared y, x squared times this will give us plus x squared k, now plus this is x into y plus k all squared. So let us expand this. This will be x into, so expanding this, y times y is y squared plus 2yk plus k squared minus, so remember our limit as k goes to 0, don't forget f of y is equal to limit as k goes to 0, so minus s squared y minus x squared y, minus times this is minus s squared y, minus times this will be minus xy squared, okay, minus xy squared, everything over k. So now let us simplify what we have, but before we go further, I find out that this and this can go, s squared y minus s squared y, so let these two animals go. So is there another thing that can go? For now, no. Let us simplify what we have, then we'll see whether there are other things that can go. So our f of y is equal to limit as k goes to 0. Our f of y is limit as k goes to 0. Limit as k goes to 0. So this is a x squared k plus this times this is a x y squared. This times this will give us a plus 2xyk, 2xyk. Then this times this will give us a plus xk squared, sk squared. This times this will give us sk squared over, okay, minus sk squared minus sy squared, everything over k. So now at this point, check if there is anything that can go. Look at this, plus xy squared minus xy squared. So this takes this. So now we have that our f of y is equal to limit as k goes to 0. Limit as k goes to 0. So we have x squared k plus 2xyk plus sk squared over k. So now at this point, what we're going to do now is that we're going to factor out our k, cancel above and below, then we now take our limits. So now let me make some space here. So our f of y will be equal to limit as k goes to 0. So we can factor out k from the above. So it will now be k into s squared is here plus 2xy plus sk over k. So this k takes care of this k. So f of y will be equal to limit as k goes to 0 of x squared plus 2xy plus sk. So at this point now we're taking limit as k goes to 0. So any place we see k, we replace it with a 0. So let's see what happens. Okay. So our f of y will be equal to x squared plus 2xy plus x get 0. So what are we going to obtain? So here we are going to have that so let me finish it here. There is no space. Let's finish it here. Okay, let's finish it here. So we have that our f of y will be equal to x squared plus 2xy. So this is what we have, okay? x squared plus 2xy. So this is already 0. So this is what we have. So now let's check if it is the same thing we obtained initially. So x squared plus 2xy. x squared plus 2xy. So don't forget what we did. This is our general formula. For f of x, you use this. For f of y, you use this. Just note that the only way to make it easy for you is this. When you're looking for f of x, just know that there is an increment in x. Okay, so what you do is that you have f of x plus h. The difference between this and this is that there is an increment in x here, which is h, and this one is that there is an increment in y, which is what, k. So they are the same thing. Okay, please don't forget. Okay, try and solve this over and over and over again, and don't forget to share the video to your friends, to your enemies. Okay, in fact, to everybody. Okay, all your friends in Facebook, WhatsApp, Instagram, Telegram, even the people that don't love mathematics, send it to them. You will see, in fact, they will love it. Okay, and they will thank you back later. Don't forget to subscribe, don't forget to like. Okay, and don't forget to what, practice, because